Hi, everyone. How many of you know what comedy of terror means? You know what's a comedy of terror? Nice. So comedy of terror is when a comic is on stage and they have no clue what slide is going to come behind them. And they would have to figure out a cogent story to say with the slides behind them. I'm pretty much in that situation because I passed on the slides to the GDS team. And after that, life happened. And now I'm on stage with the slides. But I know what I put in there. I put in there a version of a set of data points that help form my worldview on what's AI and how do I sort of contextualize it in the broader set of changes that we see around us, and how do I perceive it as an economist, right? Like that's the basis of all the slides. Obviously, in my view of the AI, if there is full concordance to whatever I'm saying, it's a boring interaction. I want you guys to tell me, like, where do you differ? You know, the way I see it versus how you see it. And I want this to be as interactive as possible. So please interrupt me when you see something, say something, just so that we can all collectively get different thought process together. So the talk is going to be a little bit tops down. So we'll start with the macro framing of what's happening broadly in the AI economy, and then we'll zoom into the micro examination of a few paradigms which I thought were interesting. So this is a graph where economists have been studying historically the adoption of various technologies. On the x-axis, you're seeing time, and on the y-axis, you're seeing the electricity production of different economies. And actually, something interesting stands out when you study electricity production. This has been there for such a long time, right? Like it's a technology that all of us have seen, witnessed. Probably all of us grew up and were born right after electricity was made available to the economies that we participated in. And even if you control for things like population, and if you control for things like the size of the economies in different aspects, you still find that the early adopters actually have a lot more technology percolation, a lot more uses of electricity, controlling for all these factors out into the future, which is kind of interesting, right? Like, so the early adopters of a technology tend to have this sustained effect that goes on for many generations. And it's kind of intuitive once you think about it, which is early adopters get to make mistakes. They get to choose use cases. They get to explore use cases, different things that late adopters can't. But there is another story lurking with AI, I feel. And that's what kind of caught my attention a little bit. So this graph that you're seeing, on the x-axis, you're seeing the relative income per capita. And on the y-axis, you're seeing the total factor of productivity. And this graph is saying a story where this is the extensive margin contribution of a total factor of productivity. So what is extensive margin? Extensive margin is, it's just an indicator in an economy to say if a particular technology is in vogue or not in vogue. Like even if 10% of the population is actually using that technology, that's extensive margin 1. And this extensive margin can be contrasted against an intensive margin. In the intensive margin, the total factor of productivity of a technology, you actually try to say how much intensity with which that technology has percolated in. And for those of us who are not familiar with total factor of productivity, that's a measure of saying how much productivity boost happened to an economy as a consequence of technology adoption. So what is the story behind this? You find that the extensive margin is rather flat. And the intensive margin is a lot more correlated with the relative income per capita. Why is this, right? Like technologists have tried to answer this question on why this is happening. Turns out, technologies are very, very recursive. Someone had to invent the camera, and for someone to be able to give a presentation, someone had to invent the LED TV, someone had to invent the clicker. All of them had to come on board at the same point in time, and each one of these technologies are now building up on top of each other. So the substrate technologies that are there ends up empowering the subsequent technologies that come about. Now, why am I bringing this in the context of AI, right? So historically, what we've seen is unless you have the substrate technology, you're not going to see as much adoption or intensive margin adoption of the new technology. Is AI an exception? And that's a key question that a lot of us have to grapple with. One of the reasons why AI could be an exception is what you're seeing is the mobile phone adoption across different companies, different economies. On the x-axis, you again see time, and on the y-axis, you're seeing the mobile phone lines per 100 population. And the second graph is showing it in the percentage terms. And what you see is there is this hockey stick that's already started in a lot of the developing economies. When we talk about developing economies, BRICS often stands to be one of those good areas to look at. And in those areas, we are already seeing a substrate technology, which is a mobile phone with the data connectivity, already happen. And people have been asking survey questions. I think someone was talking about not having a counterfactual for AI, right? Like that's truly a place that we are in. So we have to kind of deal with what's happening in the AI space through surveys. So there's a very famous survey company that actually went and surveyed lots of adults in different countries. And what they found is on the y-axis, the x-axis, you're seeing the GDP per capita, and the y-axis, you're seeing already find AI impactful, right? Like percentage of adults in the survey who said, yes, I found AI impactful. And you're finding something strange compared to the previous set of graphs that I showed, which is the developing economies are actually seeing some realization of AI. Now, I'm a skeptic of data when I see it. So one skeptical viewpoint here could be, this is just the extensive margin adoption, right? Like, there's just like a small set of people who happen to have access to the data or AI functionality, and the same set of people have been answering the surveys. So that's definitely a possibility. Only time can tell. But I do know one thing that came out of the same survey, which is they also asked the question, are you nervous about AI? And interestingly, when they asked the question, are you nervous about AI, the x-axis again here is GDP per capita, and the y-axis is, are you nervous about AI? Percentage of adults saying, I'm nervous about AI. They seem to correlate quite well. Why is that? In the same survey, they asked, okay, how much do you trust data protection in AI? And it goes back to the same interesting trend, which says that in the developed economies, people are a lot more skeptical of AI, and they are a lot less trustworthy of data protection in AI. Perhaps this is the point to solve. It's an impediment for AI adoption. Okay, so this is the macro framing. This is what people are feeling. So what are some of the other ways by which we could estimate what is going to be the impact of AI? PwC did a really good study, in my opinion. And in this, what they did was they looked at some of these micro factors where AI productivity was improving, and they used those micro factors to extrapolate what's going to happen to the economy in the broader basis. And their finding says, something to the akin of 14% of global GDP is going to increase because of AI, all the way up to 2030, and about $15.7 trillion of AI productivity boost is going to come. And they predict a lot of that to start with labor productivity improvements, and then subsequently moving into technologies percolating deeply. Very similar trend that we see for other tech adoption. There is a risk, though, to this thesis, right? And the thesis risk is that if you kind of do the math, all of economic value chain requires downstream economics to dictate upstream investments. If Starbucks is putting $20 billion in their AI initiative, they would have to make the returns. They would have to make that margin back. So when you actually add up all the infrastructure investment that's being made from NVIDIA, you kind of do a rough math to say, okay, let me percolate that down to different companies and see what's the implied revenue boost or implied margin boost that I have to see for them to be justifying the current level of investments that they are making. There is a gap today. So there is euphoric investment happening, right, in the marketplace. So that's sort of the risk that we see in the macro. We know that there is a huge promise. Some of the developing nations are a lot more accommodative, and they feel a lot more euphoric, and the investments are also euphoric. Okay, so this was the macro framing. I'm just going to switch a little bit to the micro framing. So as part of one of my previous employers, one of the studies that we did was, can we substantiate productivity improvements that we see in AI in at least a particular use case, right? This is no longer macro. Now we are studying individual sets of people, small set of people. So one of the tests that we did was, okay, let's do a treatment and a control group, right? Like classic experiment. The treatment group got access to GitHub Copilot, and the control group did not get access to GitHub Copilot. And what we did was we gave both the groups a standardized test. It's a little bit of a boilerplate code. They just had to write like a module to, I think, build a HTML server. I forget what we did, something like that. And what we saw was, and roughly, treatment and control group are divided the same. The treatment group saw something like 55% gain. 55% gain, right? They were able to do the task in 55% lesser time. So there is productivity improvement that we see in these micro scales, and there is the validity that is being done in the data. And these are very uniquely verifiable capabilities that the models have, right? Like, so the other study that the same group did, and this was done by a bunch of my colleagues, is they actually said, okay, one of the places that we do find AI to be quite useful is personas. What if we can actually ask AI a question and make it pretend that it's a person and try to get the extracted economic implication of that question? So one question that they asked AI is, would you buy a toothpaste if it were $10? Okay, it'll say yes sometimes, it'll say no sometimes. It's a probabilistic machine, you can get the probability. What if I increase the price to $12? What if I increase the price to $13? Now, there is a pecuniary interaction that us as human beings all have built in us, right? Like the demand curve is downward sloping, which means if the price increases, I'm going to buy fewer. Interestingly enough, we've coded that in our language, and that parlance made it into the training, and the AI actually tends to answer those very accurately. And you could stretch this even further, and that's what my colleagues did, which is they actually took a non-existent computer, and they asked AI how much it would buy for the non-existent computer. And they were able to actually corroborate those experiments back to good price elasticity studies that we did. So the human here, the blue one, are price elasticity studies that were done for different attributes of a computer purchase, and the gray bars are from AI. And it seems to corroborate quite well, right? Like, so there are unique verifiable capabilities that are built into these models that make them pretend like human beings in some sense. So the productivity improvements that we see are kind of valid because you're having like an AI-like assistant or like human-like assistant come out of these AI systems. And if you kind of dig deep and say, okay, why is that happening, right? Like there's something fundamental to these models that this is happening. Any guess what this equation is? It's a conditional probability. It's an LLM, right? What is the probability of the token RK, which is the current token, given the user inputs 1 through k, right? And you take all the historical tokens that were generated by the model as an input to it, and then you have the parameter set of the model. For all of us eggheads out there, this is kind of interesting, right? Like anytime you had to change a model in the past, you had to go back and change the theta. You had to retrain your model. That's classical AI. But here in this model, you have a generalizable set built in. Now, that again has an economic problem. The economic problem is, if you think about the model scale, right? Like ChatGPT, GPT-4o, right? Like it has billions and billions of parameters. The same model has parameters in it that talks about whale hunting as much as cooking tuna fish. Maybe they have a commonality and maybe they don't. But today, we're left with the same model. And this means we have to massively scale the infrastructure to be able to run these models. And this is where the euphoric investment thesis comes back in. Now, of course, somebody was asking about SLMs, right? Like small language models. Like, okay, are those models oblivious to this problem? Turns out the model quality is correlated to the model size, even in SLMs. So these are different small language models built by Microsoft, Facebook. Apple is notionally in there. They didn't release that model, but it was taken off a paper. And then you have Google's Gemma model. And on the x-axis, you're seeing the model size. And on the y-axis, you're seeing the benchmark for MMLU, which is like one benchmark data set for the model quality. And again, you're seeing like a very clear correlation between the two. Right? Okay, so this is sort of the landscape. And this is, these are the set of data points that form my worldview on what LLMs are, how do I contextualize it in the larger economy, and how I think it's going to play a role in each one of our lives individually. And what next, right? Like, how do I make sense of it, and how do I make use of it? So this is where we're beginning to explore as an organization. And one of the things that stood out to me is actually agentic coding. And I feel this is a new paradigm that is going to come about in all of software development, but particularly in big data development and data development. So this is a notional graph, obviously not real data. This is just to show illustratively what this paradigm means. On the x-axis, you're seeing the agent's level of control. And on the y-axis, you're seeing the application's reliability. Obviously, if you had a very clear router, you don't have as much level of control, right? Like, you're writing business logic, but that application is highly reliable. This is your aircraft maintenance system, or like flight management system, things of that nature. You don't want agentic behavior there. And on the other spectrum, you could have an autonomous agent that's like completely left to its own. And the question is there a middle ground, right? Like, and can you actually trade off in a more meaningful manner? And turns out, like, by creating multi-agents and structuring those agents through LangGraph or some sort of a semi-structured agentic framework, gets you the ability to both control the flow of the agents just as much as you can control the reliability of the application. So we've put this in practice in some of our proof of concepts. And some of the things that came about to me when this development was happening is I started my world in like big data development. I feel MapReduce is going to make a resurgence. For those of us who have enough gray hair and have built some MapReduce systems, one of the key characteristics of MapReduce was you could construct the DAG, directed acyclic graph, and then throw massive amount of data to it. And the DAG is essentially a repeatable compute pattern that gets you, it accomplishes what you want. Now, you had to rethink how you do machine learning algorithms using MapReduce. There's this whole paradigm of, like Spark ML, things that got built subsequently on top of that, that initial construct, right, of programming type. With LLMs, there is going to be this version of MapReduce called DG, is what I feel. It's not the directed acyclic graph, but rather a directed graph. And the reason is you could actually build into it some form of a loop breaking mechanism, right? Like, it's not saying that you can actually pass the infinite loop problem in computer science, but you can definitely build into it a mechanism to break the loop when you wanted to, which means you could introduce cycles in the graph and meaningful cycles in the graph that can iterate on the data on the fly. So that evolution going beyond the DAG could be a huge leap for data preparation for AI itself, because the AI data cycle is real. When you take think about the life cycle of the data that makes it into model and back. You generate raw data. You take your photographs, you write your documents, all of that is raw data that's generated. Now, that data needs to be ingested into a GPU, which means it's going to have a preparation and an ingestion step. And then, of course, you train the model using that data. And you do inference, and you prompt using the inference. And then there's an AI inference engine where after you've done the prompting, you get the output. Now, that creates new data in itself. And some of the agentic framework that we discussed this morning is really playing on that loop, right? Like, there's an inference coming out that is getting input into another model. So this AI data cycle is real. And now this sort of AI data cycle data preparation, coupled with the previous slide that I showed you, might introduce a whole new paradigm in which we have an opportunity as a data community to lean in. And so that is a very exciting opportunity. Obviously, for a storage solution provider like us, we provide the fastest storage possible in all of these sequence of steps. But that's, like, given that we would lean in as a technology provider and make it faster in each one of those steps. The question is, as a data community, how do we plan to lean into this ecosystem? And as data stewards and data people, how do we plan to lean into this ecosystem? With that, I conclude my talk. Thank you. Yeah, any questions?
Loads.
Thank you.
Fascinating. Let me see. Let me see one I can talk about here. There's so many. I'll ask you later. I'll ask you detailed ones later.
Absolutely, yeah.
Okay, but what you closed on about the data community, this is a discussion I've been having actually with a lot of people and a lot of these, is we don't have a good data community. Like, who's familiar with DAMA? With project management, you have PMP and that kind of stuff, and PMI certification. It's a group. American Medical Association is also a group that's a lobbying group, but also, like, discusses stuff together. And all these different components need solving. Like, the data quality is always important, right? What's your thought on, and there's great companies like yours and coming with solutions in areas, but the idea of the entire landscape is complicated, moving so fast.
Right.
How do you think we can create a real data community where people who know about the data quality problems, the business impact, the rapid change, the different things that you talked about, then there's solution providers to use rather than try to rebuild? How do you plan for the micro? All these type of, my other questions are related to this higher level question of how do we get that data community first? Because people are, even within companies, replicating, siloed, trying to run to make solutions. And then companies themselves are doing that, wasting time, not leveraging expertise of a data community to get these insights.
Yeah, that's actually a good question. I think there's, again, a lot of viewpoints here. The part that I kind of want to focus on is, let's say you take a benchmark data set and you evaluate a model today, right, like LLM today. One of the problems that people face is if the benchmark performance is really good, they don't even know if the model was actually trained on that data. Because pretty much a lot of these models have seen all of internet, right? Like if ChatGPT 4 or like 5 when it comes out, yeah, they've kind of, like the question is like, have they already seen the data that you're even benchmarking them on? And so one of the answers for a data community could be some form of a provenance check, right? Like there are other places where this has been actively solved for, where you have gold standard data sets, especially in the trading community. They have certain data sets that they'll be held out and they wouldn't be given access to in order to know whether the model is actually truly performing. Something of that sort that then boils down to a company level would be my first go-to, right? Like where within the company, if there are people who are fine-tuning models, who are actually deploying the models, we'd have to start thinking about some of these governance checks that says, hey, is this a company-specific data that we know that the LLM has not seen, and can we trust the performance benchmarking that comes out of it? That would be one of those key problems which different companies have to start actively thinking about, which is a lineage, but with a twist of model proficiency in it.
Hi. My question is on the earlier part of your presentation, so I hope there's no disconnect on the
Sure,
part.
yeah.
So 2 questions, actually. One is I saw there was an uptick in the labor market, but presumably with AI, there'll be more robotization and automation of lower skill labor tasks.
Right.
So how is that there an uptick?
Yeah, so I'm not a macroeconomist, but I'll tell you what most consensus macroeconomists are talking about. There is going to be labor displacement for sure, right? Like there used to be very famous horse breeders that we never heard about, we don't hear about today, like that we have not heard about, because the moment automotive industry came, there was like a huge displacement of jobs. I'm pretty sure my kids are not going to be employed in the same way that I am. So even in 2030 timeframe, there is that assumption baked into a lot of these models that there's going to be labor displacement, and that might, may have short-term pain, but in the long run, the hope is that there's enough part of the economy that can go focus on high-value value additions.
So maybe labor market includes both high skill and low skill.
Absolutely. All those figures shown there, they include both high skill and.
Well, I was mistaken there. I thought it's just the low. When you say labor.
Yeah, it's the economy, labor, right? Like, so.
And then the second question was that with all the growth that's we're being bullish about and growth fueled by AI, do you expect the interest rates to grow? I don't know if.
Yeah, I think I'll be out of my depth if I answered that. I do want to follow back on the labor comment a little bit more. One important thing that is worth mentioning is when we think about some of the implications of scaling up massively in AI, we need to build more data center. We need more power. There is no question about it. There is a good argument to be made that the foundational infrastructure that we need for a lot of this AI is not ready yet, right? Like at least if you take the current economy and play it forward, you'll get the Sam Altman figure, $1 trillion, $2 trillion worth of data centers. But even if we are skeptical about that and say it's 50% of that because technology evolution would catch up, that still is a lot of money to be infused and jobs to be created, right? Like people would have to go build those. So I feel like the percolation effect is very underestimated in economies. It's not easy for a lot of the microeconomists to estimate it, so it's more of a macro question. That would give you the inflationary effect answer and whatnot.
Thank you.
Phenomenal talk.
Thank you.
I didn't know it was kosher to have such technical slides. I will revise my slides.
Next time.
One is a comment and one is a question. The first comment is there are several paradoxes that are emerging. So we recently did a study on, we offered physicians, AI, and then we offered a separate set of physicians Google. So it was a controlled experiment, and then we oddly enough found that the physicians with Google outperformed the physicians with AI.
Interesting.
So I would, there's a lot of salt to be added to the data that comes out of surveys like this. I think we're still going to find boundary cases. And partly that's down to just familiarity and training. So that's one comment. The second one is more of a hot take, but I'd like your thoughts on this. Every time I hear about agentic frameworks, I wonder whether it's just, our hubris into thinking that if we need to glom this super complicated model. The scaling laws are very clear that the more data and the more parameters you give it, the better it performs. But we still want that sort of log trace, and so we break it down into these subcomponents, and then we force them to interact with each other the ways we do, and then we marvel at the logs, of how these agents are communicating. My sense is that this is just humankind's, inability to deal with the fact that, you just build bigger AIs with more parameters and throw more data at it, and it'll have that conversation internally much better than if you bandwidth limit it. So what is your take on this data lifecycle? I mean, sure, for the next 5 to 10 years, agents might be really popular, but I find it hard from a theoretical standpoint to believe that one giant, GPT-7 that has like 1 trillion parameters will not outperform 6 specialized agents. Sorry? Yeah, well, that's an economic argument, but I'd love to hear your thought on.
How do we think about it? I'll answer your second question first. I mean, again, this space is forming, like all of us are learning. But the foundational models are all multi-billion-dollar models, right? Like it's not something that every company can sort of take and train. But small language models, which often have a start or a foundation from a foundational model, but then you actually focus it down onto an area that is pertinent to your company, fine-tuning it to your company, ends up showing some interesting results. But what's even more interesting is people have taken those sort of models, which are now fine-tuned to a particular vocabulary, and then blended it with a model that is a foundational model. And when I mean blending, it's again a stochastic probability machine, right? Like it gives a token, you give that as an input to another foundational model, you get that to redirect the output in a certain manner, and then go back to the fine-tuned model. That blending often tends to outperform either the blended model separately, or either the fine-tuned model separately or the foundational model. So that experiment or set of experiments seem to indicate that the conditional probability distributions are not as easy as we think to direct them, right? Like there are so many tokens. Every token has a probability over a huge vocabulary. That's one of the reasons why the agentic framework tends to work really well, because you reduce the scope of what the agent has to do onto a very, very small set of tokens, right? The contra-argument to this is O1 preview or O1, if people have sort of used. There, what they've done is they've actually taken reasoning tokens, right? Like rather than us tell the agent like what are the set of the outputs that should come, they include a specific set of tokens that the agents use for themselves to actually plan, or rather the model uses for itself to plan, and that reasoning token tends to direct the conditional probability in a particular manner, right? So that's sort of my viewpoint on this, and we can connect more on this front. Going back to your first question, there is another survey that I want to talk about, which is actually interesting in the other spectrum. They took a rational concept, Earth is not flat, right? Like that's
Pause you for one moment. I want to get the answer, but I also have to make a quick announcement that you may have a 4:45 meeting coming up. Just take a quick look at your app. If you do have a meeting, that's going to trump content, but rest assured we're recording and we'll share everything. So just a quick note on time, and then I do want you to answer this.
Awesome. Yeah, I'll probably answer this last question. Yeah, so there was another study that was conducted where they took a rational concept, right? Like Earth is not flat kind of a concept. And then they presented that concept to an agent, or like rather to an LLM, and then they put a human being in front of it, and somebody who is a contrarian, right, like a person who is not following to that fact. Turns out, in a disproportional manner, people who interact with LLMs subsequently switch their opinion. And the reason is, as human beings, it's great to have someone there who's non-judgmental, who's kind of not going to tell you down, and is patient enough, and it's polite enough, and I heard in the agentic talk that some of the agents are even polite to each other, and that flips the human behavior. So it's a matter of learning, I feel, as you called out. Like earlier, I used to have different kind of Google queries. Now I have a very different kind of Google queries. So it's the same thing where human beings may have to learn to evolve with these machines, and that might be one of the explanation factors. All right.
Fascinating.
Yes. Perfect. Thank you so much. Would definitely like to connect later. Yeah.